In a technical age, data drives our lives. We make decisions when data becomes information. I want to talk to you about data integrity, and ES-SO has a database and procedures to ensure data integrity. Data simplicity. How can we all make performance data of our products and materials simpler so that they're easy to understand and use? And data recognition. How the solar and optical performance of the solar shading industry's products needs better recognition, especially in the building software. So the ES-SO's European Solar Shading Database, known as ES-SDA, it only has performance data that is calculated to European standards. The data is then checked and peer-reviewed by industry experts before being uploaded onto the database. The measurement requirements are exactly the same as those for the glazing industry, so we can check glass and blind performance and do all of the calculations. The database can be found at esodatabase.com. The site not only contains the data, but also a calculation engine. Detailed performance data can then be exported for engineers involved in the building design. And the site contains detailed explanations of the technology and the terms of use. So to go through the process a user would follow, if we select Dixon, and we then select external fabrics. It's a material rather than an aluminium. We select the product that we require, and we select the glazing type. And the glazing type is a reference glass that is referred to in the international standards. That can then print as a PDF, or if it was a building modeler, I could download the spectral data file. We've got options to select the properties of shading, the properties of shading glazing. We've also got the national building codes. We've got an energy performance indicator, and we can also go to all data outputs. If we select all data, as you can see, a lot of it, and I won't scroll that one down. We then have a knowledge base of all the terms that are used, and they're explained, such as GTOT, TVIS, and we have hover over boxes over the explanations. As Hervé will explain in the next presentation, there have been updates to our two standards. That's 133631 and 2, and they are now ISO standards 52022/1. Currently, our other standard 14501, which you'll find on the back of your sample cards, is through the final stage of being adjusted. That will also become an ISO standard. There are slight changes in the standards, and Hervé will go into those in detail in his presentation. But it does mean that manufacturers will have to check, because there's some slight changes to their data. It doesn't mean that the materials have to be retested, and the ES-SDA database does that calculation to convert the information to the 52202 standard. So rather than going back to the lab, you'll find that if you enter your materials onto the ES-SDA database, that calculation is done at no additional cost. ES-SDA was the first database to conform to the QualiCheck system, which is a EU scheme, and it was that is designed to improve the performance in data for building modelling. Moving forward, we've had discussions to harmonise the ES-SDA database with the International Shading Database that has been developed by Steve at Lawrence Berkeley, Steve and Charlie, and also we'll be collaborating with the Window Manufacturers Association of America, the ARC, and with the Australian Association. But ES-SDA is not just about data. For more guidance on low energy shading, we have a section that explains everything with illustrations and photographs. so you can use that to explain the technical benefits to your customers. If you then click onto one of the links, there is also a link to the new shading guidebook with a lot more information that Hervé will be explaining about. So, if we go back into history, the earliest shading we know of was developed in the Middle East over 2,000 years ago when alabaster slats were used across window openings. So we're not a new technology, we're a traditional technology, but that actually has issues for us. So then glass was invented, and shopkeepers since the 17th century have used shading to create their product. And air conditioning was invented, and we forgot that if you stop the solar gain before it gets to the glass, you don't have to pay to use energy to remove it. And then architects started to love fully glazed buildings. Regulations then changed, so we now over-insulate our buildings to keep the heat in. And as Andrew said, overheating is probably the biggest issue in the construction of new buildings. But it's easy to forget the basics. People naturally seek shade, keep cool. We also have a problem with data. This is an example of data on the back of the sample cards. If you can't see the detail on the screen, then that's the point, because you can't see it on the back of the sample card. So much information makes it almost impossible to read and understand. So this brings us to the ES-SO Simplified Data Initiative. And our recommendation is that to make the data easier for the user to understand, and we separate the information that is mainly needed for advanced building modelling from the data that is of most use to our customers. If you do that, we only really need the visible light, TV, GTOT, the heat rejection, possibly the UV for fading and dim out and block out. So if you show just those, the display is much clearer. This is what we think should be on our sample cards. For consumers, we propose an easy reference guide. This is based on the qualities highlighted in our standard EN 14501. It will make it easier for your sales team to understand the data and also enable them to promote the product benefits. They are not going to be scared by a lot of data on the back of the cards. In a technological age, data drives our lives. We make our decisions when data becomes information. So data simplicity is obviously important. But that does bring us on to a building modelling issue. Some of the simulation software that is in use is somewhat dated. We have a historic problem that many of the modelling programs have been designed to assume that the building will be air-cooled. We had a case study that we did in London, and the actual outcomes are somewhat different to the reality. Reality showed an operative temperature in this case study building of 47.5 degrees in one of the sample rooms, whereas the model indicated 27 degrees. The model showed external shading would only reduce the temperature by 1.5 degrees, whereas the reality was that it reduced it by over 20 degrees. That's not just a margin of error, that is fundamentally wrong. And let's not forget that the solar energy falling on our building is very significant. In New Delhi, consultants have calculated that the solar energy falling on just 1 square metre of glazing in a year is enough to make 40,000 cups of coffee and boil 30,000 eggs. That then is our CAS campaign to press for change. We could start a war with the building software industry, but what we actually need is a coordinated effort to advise and educate. But this then has significant financial implications for our industry, and we need to to have your support. We need to research other modelling systems and to produce guidance for users. We have to properly educate even our own industry. So we then go on to a modelling system that then works, and I think, Andrew, we can move on to Persading. Thank you very much.